Hello everyone. In the previous video for today's lecture, I missed mentioning this. Please make sure to try out these code snippets using Jupyter Notebook session that will enable you to solidify your understanding as to why the custom type person created by name tuple is immutable and why the custom type person created by record class is mutable. Please note that record class will not work in Python tutor, so you will have to use Jupyter Notebook session if you want to execute both of these code snippets. Let's do a quick recap of mental model that we have been using so far for state. I'm going to call our current version of mental model as version V1. Recall that we have been using boxes beside variables to keep track of the variable's value. I have a simple code snippet here. Line 1 is saying x equal to string hello. That's going to make us write down the value hello into the x variable box here. Line 2 is saying y equal to x, which is now going to make us write down the value hello into the y variable box. Line 3 is saying y plus equal to string space world. We are now going to update the value within the y variable box as hello space world. So what is wrong with the current mental model for state? There are a couple of issues. Firstly, it is incorrect for mutable types. Secondly, it ignores Python's performance-based optimization. We'll be discussing both of these issues in detail in the upcoming slides. Let's first fix our mental model for state by learning version V2. Recall that objects reside in heap memory and variables reside in stack memory. I'm going to differentiate heap memory from stack memory by drawing this vertical dotted line. Let's go through this code snippet one more time. When we execute line 1, which is stating x equal to string hello, we are creating a string object instance storing the value hello into the heap and adding a reference to that particular string object instance into the variable x. So the correct way for visualizing this would be to draw an arrow from the x variable box to the string object instance in the heap memory, which is storing the value hello. Line number 2 says y equal to x. When we execute this line, we'll only be creating a copy of the reference to the existing object instance. So the y variable box is now going to have an arrow to the existing object instance string hello. When we execute line number 3, which is stating y plus equal to string space world, we'll be creating a brand new string object instance which stores the value hello space world. We'll be updating the reference inside the variable y to point to this brand new string object instance hello world. Recall that y plus equal to string space world is a shortcut for mentioning y equal to y plus string space world. Let's revisit assignment operation and argument passing rules with this updated mental model version V2. Rule number 1 has to do with assignment. Let's assume that we are creating some object instance and adding a reference to that into the variable x. When we say y equal to x, we will only be creating a copy of the reference. We will not be creating a copy of the object instance itself. So this implies that y should reference whatever x references. Rule number 2 has to do with argument passing. Recall that in Python, whenever we pass arguments, we go through something which is called as pass by value. Here we are going to state that the parameter variable should reference whatever is being referenced by the argument variable. I have a function definition for function f, which includes the parameter y. Let's say that we are creating some object instance within the global frame and adding a reference to that particular object instance into the variable x. Then we are invoking the function f by passing x as argument. Here we are stating that the parameter y should reference whatever is being referenced by the argument variable x. Once again, we will not be creating a copy of the object instance. We are rather only creating a new reference to the existing object instance. The new reference is going to be stored within the parameter variable y. Let's do a quick recap of the two visualization options with Python Tutor. Option 1 is going to be the default, which is inline primitives but don't nest objects. Option V1 visualization is going to make Python Tutor add all the primitive object instances directly into the variable boxes. Option number 2 is going to be render all objects on the heap Python. This is going to represent our mental model version V2. This is the more accurate way of creating the visualization. We are now going to add an arrow from the variable box, which is going to point to the string object instance hello, and we are going to similarly have a reference from the variable y's box, which is going to include an arrow to the string object instance hello world. Even though version v2 is more accurate with respect to visualization, it can get very much cluttered if you were to visualize every primitive object instance using this arrow representation. Sometimes we'll be using version v1 if there are many data structures as part of the program, because that can make the visualization cluttered if we were to use render all objects on the heap Python option. Let's understand the motivation as to why we need this complex model version v2, which includes details about references and objects. Why not just follow the original mental model version v1 for everything? Let me give you two reasons for that. Reason one has to do with Python's performance optimization. I'm going to go through a very simple example to explain this. We are creating a string object instance which includes millions of characters. Then we are adding a reference to that particular large string object instance into the variable y. Now when we say y equal to x, we are only creating a reference copy and not creating a copy of the object instance itself. So this particular line's execution is going to be very fast. Let's go through the visualization for this example. We are going to create this very large string object instance in the heap memory. We'll be adding a reference to that particular string object instance from the x variable by drawing an arrow from the x variable box to the string object instance. When we say y equal to x, we are simply going to add a new reference to the exact same string object instance into the variable's y box here by adding an arrow from the y box variable to the existing string object instance. We do not create a copy of the object instance itself when we use the assignment operator. If Python were to do that, this particular line of code will be very slow because Python needs to copy millions of characters from one string object instance to another string object instance. With this mental model version v2, we are able to understand Python's performance optimization here with respect to assignment operation. Let's consider reason number 2, which has to do with centralized updates. I'm going to go through each line of code within this code snippet. First of all, we are importing record class type by mentioning from record class module import record class. So we are going to say from record class import record class for specifying that. Then we are using the record class constructor call to create a custom type person. We are going to mention person within the return value and also the string person within argument 1 here for the constructor call. Argument number 2 is going to be a list of attribute names. The attribute names here are name, score, and age. Then we are using the person constructor call, which is the new custom type that we just created, to create an object instance to store person Alice's details here. We are capturing this particular object instance's reference into the variable Alice. So if we were to visualize this line of code, we are going to add an arrow from Alice variable which represents the reference to this particular Alice object instance that we just created using the person constructor call. In the next line, we are creating another object instance for the custom type person by passing named keyword attribute values. How do we know that we are passing named keyword attribute values? I'm mentioning name equal to string Bob, comma score equal to 8, comma age equal to 25. So these represent keyword arguments that we pass to each of the attributes that we included as part of the custom type person definition. So Bob is now going to contain a reference to the second object instance that we just created. When we go through the next line, which is saying winner equal to Alice, we are saying that winner should reference whatever is being referenced by the variable Alice here. So we are simply going to create a reference copy, and we will not be creating a copy of the object here. So winner variable is now going to hold a reference to the existing object which represents Alice's details. So if we say alice.age plus equal to 1, which is allowed because we are using record class mutable type to create the custom type person, we are going to update the value of the attribute age within this particular object instance here. Observe that we are using the reference variable, which is Alice, and then dot in order to access the attribute here, which is the age. Then we are saying plus equal to 1, so that's going to increment the value of age attribute here to 31. Then we are calling the print function to display winner.age, even though we did not make any direct changes to the attribute value within the winner reference here. That is still going to print 31. That's because winner simply references whatever is being referenced by Alice. So if you make changes to the object referenced by Alice, you're going to see the changes within the winner reference as well. So that is exactly what is meant by centralized updates. Let's go through certain examples via Python tutor. You are going to have multiple different ways to go through these examples on your own. I would encourage you to just watch the lecture video instead of trying to follow along with the lecture video. I'll be using Python tutor to go through some of these examples to step through each of the lines of code. You have two different options after watching the lecture video. You can either take the code snippet from the slide deck and paste it into Python tutor and step through each line of code, or you could use the interactive exercises from today's lecture. Let me switch to the browser window. I'm going to search for objects lecture. Once I find the objects lecture, if I click on interactive exercises, that will show that we have the same set of examples as part of the interactive exercises. I'll wrap up this video here. In the next video, we'll go through these example problems.